Hello students, today we are going to start a new chapter, that is force and laws of motion, which is chapter 9 from your NCERT textbook. In this chapter we will be talking about the forces as well as the motion. First of all, what is a force? Force can be considered as a push or a pull. So can you see, this person is pushing and this boy is pulling. So either it is pushing or pulling, it is considered to be force. So what is the definition given over here is, a force is an effort that changes the state of an object at rest or at motion. That means whenever there is force applied, it can lead to the changes in the state of motion. State of motion can be either it is rest position or it is in motion position. Rest means stationary, it is not moving, and motion means it is moving. Rest means not moving, it is considered to be stationary. Stationary means not moving. Okay, not moving. And what is motion? Motion means it is in a moving condition. So it can change the object's direction. So what is the result of force? It can lead to the change in the direction as well as the velocity. Okay, so it can also helps in the changes in the shape of an object. So again, this one here we can see is the force is an external force which may move a body at rest or stop a moving body or changes the speed. Means all the external force that is applied over there, it can either stop or it can start moving, or it can change lead to the change in the speed, or lead to the change in the direction. So you need to remember all these points. These are very important. Change in direction, then change in the speed, stop a moving body, or move a body at rest position. What are the effects of forces? Force can move a body at rest. That means if a thing is at a stationary position, it is not moving, force can lead to its movement. And second thing is, force can stop a moving body. For example, if a ball was rolling over the ground and if someone stops it, it is due to the force. Next one is, force can change the speed. Okay, can you see this one? If any ball is coming and if you will kick it, the moving ball will gain the speed and it will move. And it will lead to the change in direction also, and it can lead to the change in the shape as well. So here in the examples you can see, from this one is in rest position and this man is giving force, so this car can start moving. And in this example, this ball was in a moving condition and this person stopped it, okay, by applying the force. And this bicycle, by pedaling it, okay, by applying the pedals, or you can say by pedaling the cycle, this cycle can start moving. Okay, in the same way, if this Batman, what he can do, he can change the direction of this ball. You can see this ball, it was thrown to him in one direction, and by hitting with the bat, he can move the ball in another direction. Next one is change in shape. You can see this person is rolling the chapati. Okay, he is rolling the chapati, or you can say he or she is rolling the dough by applying the force. So these are some of the effects of forces. Now next one is, what is a balanced and unbalanced forces? So balanced force are applied to an object when there is no effective force acting on the object. You can see here, this side 3 persons are there applying 300 Newton force, and this side also 3 persons are there applying 300 Newton force. When 300 Newton and 300 Newton forces is applied in both the direction, in opposite direction, can you see this arrow represents the opposite direction? These persons are pulling it in this direction and these persons are pulling it in this direction. So that means here also pulling it with 300 Newton, here also they are pulling with 300 Newton. So that means there will be no net movement. Okay, so there is no net effective force on the object. Object over here is the rope over here. And what is an unbalanced force? When uneven force is applied. For example, acting on an object which can change its speed or direction of the motion. It moves in the direction of the force with an highest magnitude. For example, this side 400 Newton is applied and this side 300 Newton is applied. So that means this side people, what they will do, the direction of the force will move in this direction. Why? Because they have the higher magnitude, because they are applying 400 Newton. So this type of force is called as the unbalanced force. So here also you can see, if two forces act on a body in opposite direction, if both the forces are equal, for example, at the force 1 is equals to the force F2, what will happen? There is no force applied over here. The resultant force will be 0, because this is also applying same force, and this is also applying the same force. So the balanced force cannot change the state of rest or motion of the body. So if there is a balanced force, that means if the object is in rest position, it will be in rest, and if it is in a moving condition, it will continue moving. What is an unbalanced force? Okay, if the two forces act on a body in opposite direction, okay, this is also in opposite direction, and if one force is, for example, the force is applied in this direction and this force is applied in this direction, okay, so this force is acting opposite to this one, okay, so the resultant will be what? It will move towards the greater one, okay. So if F1 is applying more force, means it will be moved to the F1 side. So unbalanced forces changes the state of rest or the motion of the body. So what you can say, this kind of unbalanced forces can lead to the change in the position. If it is in rest, it can go in motion, and if it is in motion, it can increase its speed or velocity. So what is a net force that we need to remember? You can see this box, okay. Two people are pulling in this direction, okay. Two people are pulling in this direction, and one person is applying 5 Newton and another person is applying 5 Newton. But this side only one person is there but applying 7 Newton. So altogether this side 10 Newton is applied and here 7 Newton is applied. So what will be the net force applied on this box? So 10 minus 7 is equals to 3. So the net force applied over here will be 3 Newton, and the movement will be in this direction. I hope you must have understood this. Next one is frictional force. What is a frictional force? In your lower classes you have studied like the force that opposes the relative motion is called friction. For example, relative motion means, for example, this is a box, okay, and one person is pulling this box, pushing this box in this direction, but friction always work against the pushing force in opposite direction. It always works in the opposite direction. If the movement should be in this direction, the friction will always move in its opposite direction. So it arises between the surface in contact. Can you see over here? You can see this arrow, right? So there is the contact of this box and this one is here. So for example, if a box is kept on a floor, so the contact between the floor and the box, at their contact there will be the frictional force. For example, when we try to push a table, it does not move because it is balanced by the frictional force, because it is balanced the body because it is balanced by the frictional force with the force applied over there. That is why the box cannot move. Force of friction. So these are some of the examples given over here is, for example, a ball rolling on the ground gradually slows down and comes to stop due to the force of friction. If you will hit a ball, what will happen? It will start moving, but gradually its speed will decrease. For if the ball is moving in this direction, after some time what will happen? The ball will move in slowly. Why? Because the friction that is present on the ground, it will try to stop it, and that is why when it tries to stop it, the speed of the ball reduces and at the end it comes to rest position. Next one is, if we stop pedaling a bicycle, it gradually slows down and comes to stop due to the force of friction. Here also, if you will pedal here, okay, if a bicycle is continuously pedaled, that means the force of friction which is acting against it. So what will happen? The force of friction will be high, so it will not move. So in order to overcome those frictions, we need to pedal it. Okay, so this is the another example. An object with uniform motion will continue to move with uniform motion if the force acting on it are balanced. Means like if the pushing force or the frictional force or the moving object If both the speed is same, if both the force is same, that means it will keep on in uniform motion. But if an unbalanced force acts on the moving body, then its speeds or direction of the motion changes. For example, if the ball was moving and suddenly while moving itself it was kicked by someone, what will happen? It will change its speed as well as its direction as well. So if the unbalanced force is removed, then it will continue to move with the speed that it had acquired till then. So there is an experiment explained over here, that is called as the Galileo's experiment of motion of an object in an inclined plane. So what they have done, they roll down a marble from the inclined plane. Okay, they are rolling the marble from this inclined plane. Okay, so its velocity increases when it is rolled down from the above. Its velocity will increase. Okay, so when it goes up, its velocity increases, but when it goes up the second inclined plane, can you see this one? Second inclined plane. What I was telling is, when it comes down, it comes with the greater velocity. Okay, and goes up on the second inclined plane. Okay, but its velocity decreases. But here what you have to remember is, if the inclination of both the planes, this plane and this plane, is equal, then the marble will reach the same height. Okay, same height which is rolled down. That means this marble, if it is thrown from this height, it will come down and again it will reach the same height. Okay, and if the second plane is decreased, that means if the inclination of the second plane is decreased, it will travel more distance to reach it. That means what we can say, if the height, or you can say it is little bit decreased, this inclination is decreased, what it will do, it will, if the inclination of second plane is decreased, it will travel more distance to reach the original height. That means in order to reach the same height there also, even though it will be smaller, it will move further distance, okay, to reach its original height. And if the inclination of the second plane is made horizontal, horizontal means straight, okay, if it is made horizontal, then what will happen? It will move forever trying to reach the same height. That means if it comes from here, it will reach the same height. If it is again a little bit the height is reduced, then it will try to move further. In this way, you can see it will try to cover the same height. Can you see this one? They are all in same height. So from here what we understood is, like, the marble will travel forever trying to reach the same height when it is in horizontal condition to reach the same height. Okay, and unbalanced force is required to change the motion of the marble, but no force is needed to sustain the uniform motion of the marble. So in order to maintain the uniform motion, no force is needed. Newton's laws of motion, and we are going to talk about Newton's first law of motion. Okay, an object, what does it states? An object remains in state of rest or in uniform motion in a straight line unless compelled to change that state by an applied force. इसका मतलब क्या होता है कि अगर कोई चीज रेस्ट पोजीशन में है या फिर वो यूनिफॉर्म पोजीशन में है, वो हम स्ट्रेट लाइन की बात करें, ठीक है, we are talking about only about the straight lines. So if an object is at rest position, that means no movement, or if it is in uniform motion in a straight line and there is no external force applied, so what will happen? They will always remain in, if it is in rest, they will be in rest. If they are in motion, they will be in motion. Okay. What is inertia? The natural tendency of the object to remain in the state of rest or in motion is called inertia. Okay. So इसका मतलब क्या होता है कि जो किसी भी ऑब्जेक्ट का रेस्ट पे रहने का और यूनिफॉर्म मोशन में ही रहने का, इस टेंडेंसी को हम क्या कहते हैं? इनर्शिया कहते हैं. दैट इज व्हाई द फर्स्ट लॉ ऑफ मोशन इज आल्सो नोन एज लॉ ऑफ इनर्शिया. Okay, that is why it is also known as law of inertia. You can see it in this diagram. There is a glass over here and there is a card present over there, and over the card there is the coin. If you will flip just the card with your finger, okay, if you will flip the card just with your finger, the force applied over here on the card, what will it do? It will fly away, but the coin will remain at one place. Why? Because there was no direct force applied on the coin. So automatically what will happen, once the card will fly away, the coin will automatically sink down into the glass. Examples of inertia can be, number one, if you play carom board, okay, and if you will play a carom board, what will happen? For example, these are the stakes of carom board. In the starting you must have seen, in the middle you will place all the coins in the middle, okay, and I'm making this the lowest one in blue in color, okay. Take this as, this is a carom board, okay, I'm just drawing it, okay, and here is the striker, okay, bigger one, you all know, here is the striker, okay, I'm coloring it with another one. So once you will hit the striker at this coin, what will happen? This coin will move to the another distance, but once this will move from here, what will happen? All the coins will come down automatically, okay. Only there is the movement in this, the lowest one, on which the force was applied by the striker. So this is also an example of inertia. Second one is, I told you about the playing card over the coin. In the previous one I taught you. This is also the example of inertia. Next one is, if we are traveling in a car and driver pulls the brake suddenly, we tend to fall forward due to the inertia, okay, because we were sitting inside the bus, we were sitting in a position, uniform position, but suddenly when the brakes were applied, what will happen? Like we tend to fall forward due to the inertia of the motion. Next one, if we are standing in the bus and the bus begins to move, suddenly we tend to fall backward because our feet is in contact with the floor, that is moving forward, but our upper body continues to remain at rest. So what does it mean? If we are standing in a bus, okay, if we are standing in a bus which is in rest condition, but suddenly what happens? The bus starts moving. So the upper body moves forward, but our lower part of the body still feels that it is in rest condition. So this is another example of inertia. Inertia and mass. What is the relation between inertia and mass? Okay. A body at rest continues to be at rest. This is the first law of motion I told you. And a body in motion continues to be in motion. So this property of body is called as the inertia. Just now we discussed about it. Okay. So the inertia, how much inertia of a body is there? How we will calculate? The inertia of a body is measured by the magnitude of the force required to change the state of a direction. For example, there is an object. How much amount of force is required to move it from here to this place? This is called as the inertia. So what they are saying over here is the force required to change the state of heavier object is more than the force required to change the state of the lighter body. So that means what you have to remember, if it is a smaller body, smaller force is required. If it is a larger body, larger force is required. This is because the mass of the heavier body is more than the mass of the lighter body. Okay. So you have to remember here is the mass of the heavier body is more than the mass of the lighter body. Okay. That is why we need to apply force. So you can see this one. You can see this one. The mass of the body is measured, is a measure of inertia. Okay. Mass of a body is a measure of inertia. Again, let's talk about the first law of motion. As I told you, an object or a body continues to be, or you can say they like to be in a rest or uniform motion in a straight line unless some external forces applied over it. Okay. So you can see this is a ball which is at rest position, and it will remain at rest until and unless an external force or an unbalanced force is applied over this ball. So once the rest ball, okay, got the force by this unbalanced person, so what will happen? The object now it is in motion and will continue with the constant speed and the direction. Okay, it will continuously move on and move on and move on, but unless it is acted by an unbalanced force. So that means there is something which is stopping it. Okay. So inertia also you can see you can how we can correlate our inertia and the mass. So more mass, that means more inertia. So all objects have the tendency to resist the change in the state of motion or rest. So that means every object has different tendency. Okay, they have different tendency, or you can say they have a different amount, have the tendency to resist the change. For example, this bucket will have different tendency to stop the change, and this bucket will have different tendency to stop the change, and this tendency is called as the inertia. So if we will talk about the different objects, they have the different inertia. They cannot have same inertia depending upon the mass of the body. For example, this is an empty bucket and this is filled with something. So that means this inertia will have different and this bucket inertia will have different. So more the mass, more the inertia. So that means if you will see in these two buckets, what you can identify is, because this one has less weight, less inertia than this one, because this is the heavier one. Heavier one means it contains sand inside it, so it will be heavy. So that means more inertia is needed over here. Okay, so that means more inertia means more difficult to be pushed from here. So that's it all for today. We'll be meeting up in our next video with our next concepts. Till then, bye bye everyone.